Hi, I am Kechuan Liu. In this work, we present AdaCode, Learning Image Adaptive Codebooks for Class-Agnostic Image Restoration. Image restoration refers to a series of vision tasks including denoising, super-resolution, in-painting, deblurring, and more. These tasks are inherently challenging due to their ill-posed nature. To address these challenges, GANG is commonly employed to recreate missing textures. Although effective, GANG is prone to generate artifacts due to its unstable training. To mitigate the issue and constrain the solution space, generative image priors are often employed as a regularization technique. With the introduction of VQVAE and VQGANG, the discrete generative prior has greatly advanced many deep generative models. The discrete image priors, aka codebooks, effectively store expressive and semantically interesting image representations in discrete latent space. And the codebooks are subsequently decoded to synthesize images. These generative models successfully tackle a wide range of problems, including image synthesis and image restoration. In those work, the codebook is learned through an encoder-decoder via reconstruction task. Instead of reconstructing from the encoder output, they do it from the quantized embeddings. The codebook provides rich information to represent visual parts. From another perspective, the codebook is a partition for the latent space, which is used to assign each image feature an exclusive discrete representation. However, due to the complex visual patterns, it's hard for a single codebook to capture all the patterns in natural images. The codebooks need to be learned separately for each category, for example, portraits and architectures. Previous work like VQGANG and FEMA-SR try to learn a general codebook for natural image reconstruction and restoration. However, noticeable artifacts are often observed for some specific image content. To leverage the efficient discrete codebooks and improve its expressiveness for general images, we aim to study the class-agnostic codebook for arbitrary image representations. We propose AdaCode, a novel approach to learn image adaptive codebooks for class-agnostic image reconstruction and restoration. Instead of learning a single codebook for each image category, we learn a set of basis codebooks. Given an input image, our model learns a weight map and computes a weighted combination of these basis codebooks for adaptive image restoration. Intuitively and empirically, this creates a more flexible and expressive discrete generative prior than previous work. The training of AdaCode comprises 3 stages. The first stage is class-specific codebook pre-training. We exclusively divide our HQ dataset into 5 semantic subsets based on the major image semantics. The 5 subsets represent architectures, indoor objects, natural scenes, street views, and portraits respectively. Then we train a VQGANG on each subset to obtain a class-specific codebook, which we refer as basis codebook in the following stages. The second stage is AdaCode representation learning. In this stage, we freeze the pre-trained basis codebooks and leverage a weight predictor to learn the weight maps and combine the discrete basis codebooks. The image adaptive codebook is then decoded to reconstruct the high-quality image. The third stage is restoration via AdaCode. In this stage, we train AdaCode for 2 restoration tasks, super-resolution and image in-painting. By freezing the decoder, the restoration is tasked as a feature refinement problem in the encoder. From the perspective of latent space partition, each representation of the degraded input image X is pulled towards its nearest code entry, allowing for the information loss in X to be relatively compensated. In comparison to VQGANG, where the quantized representation is from one general codebook, the combination of basis codebooks with the weight map can be considered as a better approximation which helps alleviate the discontinuity among the discrete codes. By pre-training the basis codebooks on specific semantic subsets, we can obtain rich and distinctive representations of different visual parts. Moreover, through the image adaptive weight map, the basis codebooks can be effectively combined to represent semantically meaningful content, such as the pyramid, person, animal, sky in this image, which may not be well represented by a single codebook. Now let's look at how AdaCode performs. For reconstruction task, we compare AdaCode with VQGANG and VQGANG-OX. To conduct a fair comparison, we ensure that all the methods here have comparable overall codebook sizes. We observe that AdaCode largely outperforms the competitive methods in the areas with intricate image patterns. For image super-resolution, we conduct the experiment in 2x and 4x scales. Our AdaCode can successfully restore the low-resolution image with realistic and faithful details while the competitive methods tend to generate artifacts or oversmoothed areas. For image in-painting, we adopt the same mask generation in GPEN and restore the occluded regions. We observe that AdaCode can consistently produce high-quality in-painting results across a wide range of scenes. For more information, please check our paper and website. Thank you.